Prediction can be seen as a special case of a Wiener filter, where the noise of our signal corresponds to a shift of our signal into the past. So our goal is to make a good estimation of the present sample of our signal based on past signal samples. Here we mean by good, again, in a mean squared error sense. So basically we can now take our Wiener filter formulation and specialize it to this case. So we can take a look at our matrix formulation, and we have here our matrix A times H transposed equals X. So this means that the input to our filter is always starting at one sample in the past, going down further into the past. Its goal is to estimate or predict the next coming sample. So basically this means that instead of additive white noise, our distortion is now a delay operator. Unfortunately, this is a linear operator. So now we can again use our approach with pseudo inverses to obtain our mean squared error solution. It's given by this equation here, with the matrix A now defined as our above matrix. So this now also leads to a statistical description with A transpose times A conversion to describe these equations here. So this is plausible because now y of n is just the delayed signal, and the autocorrelation function of the delayed signal is identical to the autocorrelation function of the original function.